to go in one direction and it's hard to reverse, we can think of a hash function. So, one-way hash function. Easy in one direction, and it's hard in the other direction. So, why f of x is easy given f of x, it's difficult to find x. So this is pretty much a one-way hash function. The most popular hash function is called MD5, message digest 5, and another one is SHA1, secure hash algorithm. So we have the original document, we compute a hash through this one-way hash function, and what we can do with that is attach it as a signature in the document. So this method is used for digital signatures, and the reason we need that is because if, let's say, we have a document on paper and we want to make sure the document is authentic, we can ask a person to sign it. It's easy to make a difference between original check with signature and then take the check, make a photocopy, and present the same document. I mean, it's easy to see one has original signature and the other one is a photocopy of the check. That photocopied check probably would not work if you try to deposit it in the bank. But with digital form of documents, it's actually possible to tell the difference between the original and the copy. So we need some way to attach a signature to these documents. And we do that through this one-way hash function and affix that into the document. When the person receives this, they compute the hash of the sender by following these algorithms. And the computed hash should match the hash which is affixed into the document. Now, when we talked about these public and private keys, these are actually obtained by a third party called certification authority. This is a third party authority which what it does is it verifies our identity, that we are who we say we are. So we go to them and ask them to issue us a set of keys, public and private key, where let's say we present our ID, our passport, or anything else to prove that we are who we say we are, and they say, okay, I'm convinced of your identity, I'll go ahead and issue you these two keys. And so these keys, one of them is made public, and that can be used to produce hash or to encrypt things and the private key stays on our local machine and it's used for decryption. So these are not some random keys, but they are provided to us by an authorized agency. So let's see what kind of protection mechanisms we have that we can use on the operating system. So the computer system consists of a bunch of objects, such as files, printers, CPU, memory. All of these things, we'll call them objects that the operating system manages. So we will consider an object, things as hardware, CPU, memory, and disk, and software, processes, files, databases, and then what we can do is divide these objects into certain domains and provide permissions to those domains. So the domain will be a set of objects and the rights or permissions that we have for these objects. So it will specify an object and the operations which we are allowed to perform on this object. So in this case, the right means a permission to perform certain operations. At any instant of time, each process is running in a specific domain. So, for example, a process which is running in this first domain has read permissions to file 1 and has read and write permissions to file 2. This printer happens to be in both domains 2 and 3 at the same time. So if a process is in domain 2, it has read and write permissions for file 1, read, write, and execute for file 4, file 5, read and write, and it also can use the printer. So by dividing the system into objects and specifying permissions for each object and placing it in a specific domain, we can provide certain level of security for the objects on the system. There is another way to look at it. This is what Unix does. It's called a protection matrix. So each box will list the right that the domain contains for that object. So these are the domains, are the rows, and the objects are the columns. And so each box is showing the rights for each file in the particular domain. So for file 1 in domain 1, we have read permissions. For file 2, we have read and write. For file 4, in the second domain, we have read, write, and execute, and so on. Another way to do this, so in Unix we get this protection matrix. In Windows we have access control lists, or ACLs. In that case, we associate with each object an ordered list, which contains all the domains that may access the object and how they can access the object. So the process is running and has an owner, and other than the owner, there are other users. And the associated with the file is a list that specifies for each user what permissions the user has on that particular file. So for example, the owner of this file 1 is A, and A has read and write permissions for that file. B is another user that only has read permissions. And this list is called the access control list, or ACL. And so this ACL is provided and maintained by the operating system, so it runs in the kernel. So that functionality runs in kernel mode. If we try to compare this to the Unix system, the way we can think of it is as each user represents a one domain. Because remember with Unix, it was a domain that had the permissions defined. Here we have users for which the permissions are defined. So we can think of as each user being a different domain. Now, other than read, write, and execute permissions for files and other objects or data, we also have capabilities which can be attached to each domain or to each user. Now, these give permissions. What kind of permissions the users have, for example, read, write, and execute is an example of permission. And capabilities are certain operations that they can perform on the system. Example, or you could think of these as rights. Example would be a copy capability. Remove. Destroy an object permanently. So is that particular user allowed to copy the file? Is it allowed to remove other users from the permissions of the file? Or is the user allowed to delete this file? And other operations on the system, such as installing software, configuring the firewalls, allowing remote connections. All of these things are rights that the user or is capable of doing on the system, and they are defined in another list called capability list or C list.